Hi everyone, this is Notes A for our very first unit called Linear, Exponential, and Quadratic Functions. So I'm going to fill out these notes and you're just going to follow along with me, and then hopefully you'll be able to start our first checkpoint. So we start every single set of notes with something called the objective. An objective is, what is the goal? What are you getting out of these notes? So the first thing I ask you is what is the objective today? So I'm going to show you what the objective is. I want you to pause the video and type or write out in this box what the objective is. So our objective is this yellow sentence. So again, go ahead and pause this video, type this out, or write it out. So our objective is that I, which is going to be you, can understand the difference between linear, exponential, and quadratic functions by looking at a table. So we are only covering tables today. We'll add to that later on and do equations and graphs and pictures, but right now we're just doing tables. And hopefully you've heard these words before: linear, exponential, and quadratic. So that's our goal today. I'm going to give you a table. You're going to tell me if it's linear, exponential, or quadratic. So again, that's going to go in that first box. Next, our next box down here, there are a few rules that we have to follow when it comes to tables. So again, I'm going to show you those rules. You're going to pause this video and you're going to type or write the rules in this box right here. Okay, so here are our 3 rules. Go ahead and pause the video and put these 3 rules in that second box. So our 3 rules, and they're not going to make sense at first, but I'll show you how they're going to work. So if I give you a table, and rule number 1, if the first difference is the same, then that table is going to be linear. Rule number 2, if I give you a table and the first difference is not the same, but it's being multiplied by the same factor, then that table is going to be exponential. Rule number 3, if the first difference is not the same or it's not being multiplied, we're going to try the second difference. And if the second difference is the same, it is quadratic. So you can see I'm giving you all 3 rules for how to tell if a table is linear, exponential, or quadratic. So let's get into our first example, and hopefully these things start to make sense. So our first example looks like this, and here's what a table looks like. Hopefully you've seen a table before, but I'm going to ask the question, is this table linear, exponential, quadratic? Just by looking at it right now, I have no idea. I don't even know what it is. So I'm going to show you how to work through this table, and then you'll be able to use our rules to figure out what it is. So every table has an X and a Y column. For these problems, we're actually going to not even look at the X column and really just focus on the Y column. And that's because the Y column is like how something is changing. I want to figure out how something is changing. So the first thing we're going to do is this next column over here, which is the first difference. In math, difference means subtraction. We're finding the difference, we are subtracting. Now, what I want you to do though is I always want you to work bottom to top. So we're going to start at the bottom and then work our way up, and we're going to be subtracting. So I'm going to start with 24 and I'm going to subtract 21. So I'm doing 24 minus 21. Okay, if you put that in your calculator or you just do it in a fast math in your head, 24 minus 21 is going to give you 3. So this first box, I'm actually going to type in or write in 3. Please fill this out in your notes as well so you have it to look back at. And I'm going to work my way up. So the next number that I have, I'm going to start with 21. And I'm going to subtract 18. So I'm going to do 21 minus 18. If you put that in your calculator, again, you will get the number 3. So type that in the second box. And let's keep going up. Now I'm going to start with 18 and do 18 minus 15. 18 minus 15, which hopefully you're seeing a pattern here. That again gives me 3. And then my last one is going to be 15 minus 12, which is 3. you're going to start every single table the same way. The first difference, work bottom to top, subtract. So I'm going to go back to my rules and let's look at these. Rule number 1 said, if the first difference is the same, it's going to be linear. Well, let's look. Is my first difference all the same numbers? They are, right? They're all the number 3. So when I figure out if a rule works, I can stop. So the first difference is the same. I know this table has to be linear. So over here, I'm going to circle, or you can highlight, or you can even erase these other ones, whatever helps you know that this table is linear. Now, I'm also asking the question, how do you know? Well, I know because my rule says the first difference has to be the same. And here, the first difference is the same. So I'm going to say first, and I'm just abbreviating difference to diff. First diff is the same. And that is a perfectly fine explanation. That tells me you know why it's linear. Okay, that is example 1. Let's do it all over again. So here is example 2. It's a brand new table, and we're going to do the same exact steps. So I'm going to ignore my X, and I am just looking at my Y. And again, I'm going to work bottom to top. And I always start the same way. I want to find the first difference. That means subtraction. So let's do this. I'm going to first do 32 minus 16. Please make sure you get the right answer. I don't care about it, taking a little bit longer, typing the calculator, but 32 minus 16 is 16. Okay, let's keep working up. I'm going to do 16 minus 8, which is 8. I'm going to do 8 minus 4, which is 4. And then lastly, I'm going to do 4 minus 2, which is 2. Again, when you find the first difference, stop for a second and check your rules. So let's go back. Rule number 1, if the first difference is the same, it's linear. Well, let's look here. My first difference this time is not the same, right? I don't have all 3s or all 2s. I have a 2, a 4, an 8, a 16. Those are not the same. I know right away that this table, I'm going to actually cross out linear. I know it cannot be linear. Okay, let's go to rule number 2. Rule number 2 said, if the first difference is being multiplied by the same factor is just another way of saying number. So this is saying if the first difference is being multiplied by the same number, then this table will be exponential. I see a lot of students not check this step. You have to check and see if rule number 2 works. So we want to figure out, are these first differences being multiplied by the same number? So I want you to ask yourself, start with 2. Oops, this is 16. Start with 2 and 4, right? Is there anything you can multiply 2 by to get you 4? And hopefully when you think about that, you know that 2 times 2 would get me 4, right? That's a simple multiplication problem. But in order for this rule to work, you have to be able to multiply everything times 2 to get to the next number. So watch the next part. If I did 4 times 2, does that get me 8? It does, right? 4 times 2 equals 8. So that's good. I'm seeing that multiplying by 2 works again. How about this last one? What is 8 times 2? Well, 8 times 2 is 16. So what I'm seeing here is that I'm multiplying by the same number and it's working. So that is what rule number 2 is. When you're multiplying by the same number, then that table has to be exponential. So I know that this table, I'm going to circle or highlight or cross out the other ones. This table is exponential. And for that question, how do we know? Well, the first difference is multiplying by the same number. And that is, again, a perfectly good explanation for why this is exponential. Please always check to see if multiplication works. Students always forget to check for multiplication. It will work sometimes, and that will be exponential. Okay, our last example together is example number 3. And it's a brand new table, and we're going to do it all over again. So I'm going to cross out my X column, and you don't have to cross it out. It just helps me focus on what I'm looking at, which is only the Y. We're going to find the first difference, and we're going to subtract always bottom to top, bottom to top. Okay, so here we go again. I'm going to do 60 minus 40. That is 20. I'm going to do 40 minus 25, which is 15. I'm going to do 25 minus 15, which is 10. And then I'm going to do 15 minus 10, which is 5. All right. When you do the first difference, stop for a second, check your rules. So rule number 1, is the first difference the same? When I look at these numbers are not the same, right? 5, 10, 15, 20, not the same, not the same. So right now I know linear does not work, okay? Exponential, are my first differences being multiplied by the same number? Well, let's look and kind of talk it out. When I look at 5 and 10, is there anything times 5 that could get me 10? Well, I do know that 5 times 2 equals 10, so it's possibly exponential, but again, it has to work every single time. So what if I did 10 times 2? Is 10 times 2 15? It's not. 10 times 2 is not 15. So I can see right away that yes, multiplication worked, but it didn't work every time. So it is not exponential. So I'm going to get rid of those, and I'm going to cross out exponential. Okay, so that leaves me with maybe a quadratic. Well, let's go back to my rules. So let's read rule number 3. If the first difference is not the same, it's not, right? We just saw that. And it's not being multiplied, it's not. Then we're going to try the second difference, So let's go back. There is this last column here that is called the second difference, which just means we're going to take the difference again, but this time we're going to use these numbers. So again, we're going to do bottom to top, and we're going to subtract all over again. So I'm going to do 20 minus 15, which is 5. I'm going to do 15 minus 10, which is 5. And I'm going to do 10 minus 5, which is 5. Remember what that law said. It said if the second difference is the same, it is quadratic. My second difference is all the same. So this table is quadratic. We're going to circle it or highlight it. And when it says, how do you know? Well, for this one, the second difference, I'm going to shorten that again, difference is the same. So those are your only 3 options. So let's review again quickly. When your first difference is the same, it's linear. When your first difference is multiplying, it's exponential. And when your second difference is the same, so if the first 2 things didn't work, but your second difference is the same, then it's going to be quadratic. Okay, please copy those rules down so you can look back at them. The next 3 slides, as you can see, say you do. So try them on your own. See if you can figure out what they are. Are they linear, exponential, or quadratic? I can always check your answers for you to make sure they're good. There's another you do problem. And then finally, the third you do problem. Try all of them. And then if you could, finish with the exit ticket. So when you're in your notes, you can actually click on these words and it will link you to the exit ticket just to see how you did with these notes. You can use your notes, use a calculator. It's not like a test. It's just for me to see how you did. Any questions, please let me know. But now you can start checkpoint number 1. Just make sure you're following these rules. Good luck.